Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, I'm going to do an improv about one topic. It's a true or false, or like a 0 and 1, or a 1 and 0 in term of math. 1 is true and 0 is false, and then or sometimes you can represent that as a color as well, white and black. White being true and black being false. So I'm gonna play around with that. So let's warm it up a little bit. So go to compositing, Sverchok. Right away, I will start with a grid. Grid is the simplest thing. If you're not sure about 3D, do it in 2D first, and then it's gonna be clearer. So start with a plane. Viewer, draw. I'm gonna save this and call it true false. Let's make a pattern like a checker pattern. Is it like something that's easy to do? By now you should be able to make a checker pattern, but sometimes it's not actually that obvious. Okay, I tried it many times, but every time I make it, my brain is like, okay, how to make like checker pattern? It's always a funny thing. So we have a grid or a plane in a plane node, and then we can center it out, do whatever. We get this grid pattern, of course. I'm gonna show you something. So if we use another viewer draw and then use center polygons, we can, and we should be able to get the center of each polygon. Yeah, there you go. That's should be showing. I'm gonna give it a different color for that vertices. I'll make it thick, maybe different color like red or something. Okay, view top. Okay, so that's the result at the moment. We will draw, and the points, each points representing the center of each polygons from the plane. Cool. So we can use those values. Next thing to do, I will create a bmesh viewer. I'm gonna switch to cycles, and I'm gonna output this plane. So I'm gonna turn off the preview. Gonna output the vertices and the polygon, and now it's become a plane, just a simple plane. And for the plane, I will colorize each and every face using vertex color. Okay, so I'm gonna give it a material first of all. Material.001. I'm gonna assign the same thing here, and then for that plane, I'm gonna give it a color. So I'm gonna use Sverchok vertex color new, and this same object goes in there. And for the color, I'm gonna colorize the face, not the vertices. Remember the face. And the next thing to do, I will test the color first of all. Let's use random vector for now. Just give it a like 64 random color, plug into the color. So this is the setup so far. Still pretty simple, and we should be able to see the material now, because in the latest Blender 2.78b, we should be able to see color vertex in cycles. If it's not showing, because I have not connected the attributes from Sverchok, svcall, plug into the color, and there you go. That's a random color from the top. Okay, now the next thing I will do is to give it a checker pattern color. To make a checker pattern, there are many ways to do that. You can actually start with just a range of number, like from 0 to the last index number, like 0, 1, 2, 3, 4, 5. Make that first, like a range integer, for example, and we know that we have 8 by 8 actually 8 by 8 actually give us 64 vertices, and probably we only have 49 faces. We can check it out using the center polygon here, using index viewer index, plug in this guy and that guy, so we can see, okay, 0 1 2 3 4 5 6 7. Actually we only have 6 by 6 or 36. We actually have 42 somehow. Oh, actually 48. 6. I was expecting to have like a 64, but maybe the number is a bit strange. Oh, 49, actually 49. 7 by 7. 8 by 8 points, 7 by 7 polygon face. Okay, and then 7 by 7, that means 49 number here. Start count is actually 49. Start step. Okay, this should give us a number 0 48. Yeah, that's okay. 49 numbers. And if we just plug this into the color, it's not gonna work. Color itself need 3 colors RGB, and so far we actually we did give like a random vector, which is random 3 colors for the color. Random vector, normally you can use it for position, but I use it for color. Now we have this range of number from 0 to 48, which is 49 in total, and we want to use it as color, and color goes between, the value goes between 0 and 1 for RGB. So a lot of concept there, and we want to turn this 0 to 49 into 0 and 1, black and white. So for that we can use modulo, I believe, math modulo, not sine, it's a modulo, and maybe this is 2, and let's look at it from using the stethoscope. There we go, it's a 0 1 0 1 0 1. If we give a we use the modulo function and then give it a 2, it will never reach number 2. It's kind of, it's doing a division and whatever, like I'll explain a little bit. My math is pretty basic, I think, but if we divide all this guy by 2, which is like modulo 2, 0 divided by 2 is 0. 1 divided by 2 is also actually 1. I think 2 modulo 2 will give us 0, because that's actually what's left over. Like a 2 can be divided by 2, then the leftover is like 0. But 3 divided by 2 is like 1, but we have 1 left. See, 3 divided by 2 is 1, because 1 times 2 is 2, so 3 minus 2 is 1. So modulo gives us that kind of pattern. Whatever left after the divisions, and we can use that as a color vector in. Plug this guy in, plug that guy in, and we have red and black, because currently I'm just plugging in. I'm plugging in this 0 1 0 1 0 1, and that pattern goes into this guy, and then the pattern is like red and black. Of course, if I plug this into X Y Z, I get a 0 0 0 1 1 1 0 0 0 1 1 1. So that's okay, that's a pattern. So we have a checker pattern. That's exactly our plan. For the random color, for black and white, these are true or false. We can also use random number generator if we like. And the same thing, we need to plug in a vector. With random number generator, of course, we need to set it up. What's the size? In this case, 49. low and high 0 and 1, so we don't want any other number than rather than 0 and 1, so we have this more random result. Plug that in, so we have that. The nice thing about random number generator is we can randomize the seed, so we have different results. Plug that to XYZ, we get also some kind of variations, 0 and 1. It's get a little bit more interesting, I think, if we increase the number. Let me try. Make this like 100 or 400. Actually, make it 100 first. 100, 10 by 10, 100 vertices, but 81 polygon face. This is what we get. So we can hide the index for now and hide the points. So we start to get this kind of pattern. Okay, so that's interesting. That's like the coloring of the grid. Whether it's like checker pattern, you need to give it 81 value, checker pattern or random pattern. Sometimes you also want to have like something that's more like fractal. Like fractal is interesting in itself. It gives you like kind of like a fractal pattern. This guy is expecting vertices. So for the vertices, we can use the center polygon because it represents one color, one polygon face. So that's a fractal pattern right there. You actually get a grayscale. It's not like just black and white. And we can tweak this guy. Even more interesting if we move the vertices that comes in using like a vector math, and then now you can see the fractal, the noise kind of moving through the pattern. It's whether it's like in the x axis or in the y axis. It looks like the matrix there. Fractal, it's going up and down, and then the z axis actually give you that kind of result. Very interesting. Fractal works, and there's also vector noise. Vector noise, it's also expecting vertices, so that thing can goes in there, and you can try all kind of different pattern. Perlin should give you something, but currently we don't see anything. I think because of wonder why it's something broken. No, we still have value. This guy is red. Maybe it's unhappy about something. Not vertex color new. We cannot copy sequence with 3 to array axis with dimension of 4. Well, oh, actually, oh, because the output is already vector, so that's the problem over there. So I'm gonna keep this guy, the fractal, and plug this guy in. So we have already like multiple way to generate this kind of black and white pattern. With a fractal and noise, we get something that's more like a grayscale. So we have a little bit more interesting result. I'm gonna keep all this. So 1, 2, 3. I'm gonna group it. So whatever output of this RGB should give us some kind of pattern. So the noise give us this, but we don't want this random color, even though it's nice. We can keep it scalar, or what can I do? Average the vector, maybe vector math. And there's this averaging. Cross dot adds length, distance. Distance will actually work as well, but not actually. There is average somewhere. List math. List math will average based on the total. vector normalize, probably what I need. Okay, normalize, and hopefully this gives us a good color result. Oh, that's actually normalizing the value, and I'm still not getting black and white or grayscale. I guess we can just use the scalar output of this vector noise and then plug this to XYZ. This is another way to do it. There you go. That's the result. Maybe we can normalize it between 0 and 1. Interestingly, we don't get normalizing noise actually give us like grayscale. That's very interesting. Anyway, the cell noise actually will give us something that's more like black and white. We still get grayscale. So in order to get black and white, maybe I need to round it. Round the value from noise. So math here, and just round it so it's either or, floor it, or round it, or ceiling. That one of these will give us the rounded value, and for that we get like a black and white. Standard Perlin, cell noise. Now they're just either black or white. With a noise like Neo Perlin, it's taking vector's position as the input. If you want to control the noise a little bit better, normally I'm using a vector math and kind of scale it using multiply scalar. So this kind of give you the control over the noise, and you start to see the pattern a little bit better. So there you go, and see if I'm translating the noise pattern. It's more clear if we actually increase the number of points. So instead of 10 by 10, 100, make it maybe 40 by 40, 1600 polygon phase, 1600 pixel. These days we take for granted all these pixel numbers, pixel crunching numbers. 40 by 40, 1600 pixel is actually pretty big. These days your computer monitor is probably like 800 by 600, or no, that's like the minimum. Even like your smartphone pixel value is so high, it's almost like it's actually higher than the magazine print, I think. But we are using the smaller number just to see the noise pattern, things like that. See, I'm controlling the noise, how big it is. I like seeing this kind of like Perlin noise sometimes. It's very soothing sometimes. And see, I'm kind of translating in X and translating in Y. You can also translate in Z. Sometimes Z is more interesting. You actually, if you look closely, this kind of pattern, you are seeing it. If you're looking like a fire or like a rain, when it's raining and then you see the pattern of the rain that falls into the ground, you can see some kind of Perlin pattern. You can also see it in lava or some animal skin pattern. So black and white make it easier for our eyes to see what's going on. Voronoi, you see, that's Voronoi. Voronoi pattern should be like bubbly looking sometimes, depending on which Voronoi. Crackle give you a cracking kind of pattern. Let's see. It's not so obvious if it's like that small. It's some kind of like looks like a bacteria. Cell noise is actually super interesting, even though it's a bit more random. I used to like just Voronoi. Voronoi, now I like cell noise. Cell noise actually give you kind of natural. It's totally random, out of pattern. So there you go. That's some kind of exploration of black and white. Maybe I can milk this a little bit more. currently it's just the output is just color, but in reality you can use all this value for the vertices, edges, or polygon of the mesh. So instead of outputting a color, you can use this to push this guy. Maybe I'll show you quickly. So if you like using a vector of this guy, vector point, but we need to push it into the center polygon, so we need another output. Oh, we already have the output. Okay, we have these points, right? And we have the color. We can actually push the points using the color. This is like a preview for the next video. This is the color, and this is the original points, and mix them together, and you kind of pushing the points, or in this case it's moving the points in 3 directions. But if you're separating the X, Y, Z, and just push it in one direction, you should be able to see the points being pushed up or down. So whatever it's 0, it should stay down. Whatever it's 1, it's being pushed up by 1 unit. So there you go, that's the result. Yeah, so that's I guess that's pretty much it for this live noding video. Hopefully it's useful. It's interesting to think about just true or false or black and white. This is like the most basic, but also because it's so basic, you can kind of use it. And you will use this concept anywhere as you continue on. So yeah, if you have any question, feedbacks, and you want to add what I was talking about, just let me know in the comment section below. And thanks again for tuning in. I'll see you in the next video.